You should hopefully see my screen. I have the same windows open that I did earlier, so and at the same size. So I'm hoping it is readable.
Yes, it is.
Good, thank you. Okay, so questions you may have is what kind of machine learning tools are installed at HPC2N and UPPMAX, and how do we start those tools, and how do we deploy GPUs at HPC2N and UPPMAX? Well, the first question here, what kind of tools are installed? You got a partial explanation, at least, under the installing packages here at the end, where you can see at least some of the more common ones are listed, where you can see how you find them, with the mention that TensorFlow should be found in the Python ML packages at UPPMAX. And we just saw where in the section that Pedro just held, how we deploy GPUs at HPC2N and UPPMAX. And starting the tools, that is loading them or installing them, of course. So let us look at the installed machine learning tools at HPC2N and UPPMAX. And there will be some code along and demos, and I may do most of it as demos, but there will be time for exercises, and there should be at least one code along for those who can either use Kepnikais or Snowy. And Python, as you know, is not that fast. I mean, it's an interpreted language, but it's still quite suited for machine learning, simply because it's easy to code in, and that is very useful, because often you have to make many different versions, try it out many times before you find exactly how you want the solution to be. You will need to do a lot of experimentation, so it's nice to have a fairly simple program to look at. And another very important thing is that it's very much used for machine learning, which means there are many, many packages already written and new being developed much of the time. So because of that, it's a good choice for machine learning. And some of the more popular ones are PyTorch and TensorFlow and scikit-learn as some of the libraries that are very common, and they are all available at UPPMAX and HPC2N. And so are several others. I mean, you have front ends like Keras and things like that. And in these examples here today, we will look at PyTorch and TensorFlow and how to run them at UPPMAX and also at the HPC2N. And some of the examples come from these pages here, and they also have other examples that are quite useful for beginners. So this is a good place to go and learn more about how to make some simple scripts for machine learning in Python. So let's start out by looking at PyTorch. PyTorch, it has an n-dimensional tensor similar to what NumPy has, but it can run on GPUs. And it has automatic differentiation for building and training neural networks. And the example we are using in this course comes from the official PyTorch page, which is linked here. And the problem is of fitting y equals sinus x with a third order polynomial. And we will run an example as a batch job. And this here, if you want to look at it, is the Python code. And you can see it's importing Torch, which is for PyTorch, and it's also importing math libraries. And this is the link to the beginner examples using PyTorch, which is a good place to go and take a look. So if you're going to do this at HPC2N or UPPMAX, either do a batch job or run it interactively on compute nodes. And you should remember not to run the long or resource-heavy jobs on the login nodes. I just want to repeat that because people end up doing it sometimes, and then their jobs get killed, and that makes no one happy. And another thing is the login nodes don't have GPUs, and that's also something to be very aware of, because we can see that many users who are running machine learning code clearly think they are using the GPUs, and they are not. So it's very important to actually say in your batch script that you want to use the GPU nodes, because otherwise you will run it on a CPU instead. And that may not be what you want to do. So let's look at an example script for running this. And this is on the Kepner-Kaiser. And this assumes that this script we just saw from Python is called PyTorch _fitting _GPU.py. And here it's more or less the same as we have done already. You can see you are loading in this batch script, there's the regular introduction here. And remember, on UPPMAX, you will put a -L after it. And then you put your project ID, you ask for how long it takes to run, and this is a short one, so I'm assuming 5 minutes. It may not be correct, but we'll see. And then I am splitting the output in error and output. And then I'm asking for one V100 GPU. Remember, on Kepner-Kaiser, you need to say what type of GPU it is you're using, whereas on UPPMAX, you would not need this marked succession here. You would just use GPU colon and number, which is 1 on Snowy. And then you remove when any modules you have loaded and load the ones you need. And here I am loading PyTorch and the prerequisites. And the PyTorch module will load many other things, including a Python that is compatible with this. And then I'm running the code with srun Python and then the name of the Python script. And I have it here in directory on HPC2N here, PyTorch fitting _GPU.sh. So you can try that if you're on HPC2N. And otherwise, the similar one, but for UPPMAX, is on UPPMAX. And I just want to open it here briefly to show you that this is the one you would use to run it on UPPMAX. And you would run it on Snowy. And you remember you need to change this here to what you called your directory.
Maybe we could ask if people are using Rackhammertool here or HPC2N. We have 2 students.
That's true, yes. What are you using? Is anyone using HPC2N?
I'm using Luna.
Okay. And
Good.
okay, but I mean, then you should be able to probably fairly easily adjust these. So,
Yeah, hope so.
Yeah, I think so.
yeah, it should be very little difference. It's just checking what the names of the modules are. So. And on UPPMAX, we can run it as an interactive Snowy session, and I'm going to do that now because it's easier to see what's going on, maybe, I don't know. So let us copy this here. See if it looks correct. It looks like it's okay. So let's start this. And it will take a little while for it to start. Not so long, it seems.
And you can notice that Birgitte required 1 hour and 1 second. So that's hard code to make it work. Otherwise, the partition will not work, basically. It's a weird thing, but it's just to accept.
Yes, I found by trial that it didn't work otherwise, because I didn't know this at first. But then I read back and saw, yes. Okay, so what I'm going to do now, I'm going to see where I am. I'm in the UPPMAX directory, but since I'm running interactively, I'm instead going to switch to the program directory here. And here you can see we have this program, PyTorch fitting, this one. So what I'm going to do now is that I'm going to make sure that I have the right things loaded. I have the UPPMAX system files loaded, which is good, because yesterday when I was testing, I had not, and it led to all kinds of bad things. So let's not think of that. Let's just be happy it's loaded. And I believe that you said it was best to load Python packages first. If I could spell, it would be good. 395, and then it's for GPUs, and then I have this. So let's do that. And then we are here. So we want to run this one. So what I'm doing is saying srun and then Python, and then I'm going to copy this. You can click on something and then copy it by clicking on the middle mouse button. That should work. So let's see what happens now. It should not take too long considering we are on an interactive session. Yes, calculated it. As you can see, it went quite fast actually. And if you wanted to submit it as a batch job, we could try do that, and then I will do that on HPC2N so that I keep my interactive session and don't have to get another one for later. So I am going to look at this one here. And I need to change the here, the project ID, and I'm going to use the sysop one, which obviously you wouldn't be doing. And then I will change this to where I have my stuff located. Which is here. And then it looks correct. So I will save this, and then I will submit it. And then I can show you how it looks here, because it will take a while to run. It may not even run while we are doing this, because it is now waiting for access to one of the GPU nodes, and they are quite heavily overloaded on Kebnekaise right now. So I will just let that sit and then look back on it later and see if it has run. So I will continue on to TensorFlow. And the examples we're using here are from this place here, the machinelearningmastery.com. But there are also good examples on TensorFlow's own page. They have quite a lot of tutorials that are quite nice. And in this case, I'm using TensorFlow 260 CUDA 11.3.1 on HPC2N, and also Python 3.9.5, which is compatible with that. And at UPPMAX, instead, I am using the TensorFlow that is within the Python ML packages, and that is also Python 3.9.5. So what I'm going to do now is that I'm going to try and run that on UPPMAX. I will just quickly show that there is now very little difference to how you would use it for PyTorch. Instead, you would say you are loading the TensorFlow module and its prerequisites on HPC2N, and the prerequisites is the SciPy bundle, which has Python and many other things, and then OpenMPI and GCC, and it's in compatible versions. A nice way of doing that is that you can type module load, and then if you know that the Python you want to use has GCC 10.3.0, for instance, then you load that, and then you can look at which ones are now available, and each time you have loaded one module, there will be fewer options left, so you will not be able to load a module that is incompatible with these two if you have already loaded them. If you need a virtual environment, which I believe we did because we needed scikit-learn, yes, and on HPC2N, and then you run it with Python and your TensorFlow program. But on HPC2N, we need to install scikit-learn because we don't have one available for this version. There are scikit-learn installed, but not for this version. And on UPPMAX, there is an example here that can be used. And I will try run that like that in a moment. But first, I'm going to try and run it directly the same way as I did here with the PyTorch. So I'll show you that I have it somewhere there, example. And I believe that should work as it is. Just give it a moment. Meanwhile, I will check if this has run at HPC2N. It has not. Still sitting in a queue. I could check how long it thinks it will take. It thinks it will start 1825, so I'm not going to wait for that. But you can see the TensorFlow program worked on UPPMAX, so that is fine. And I'm just going to also log out of the interactive session like this. And as you can see, I'm now back on Rackham 1. I was previously on S159, but now I'm just going to go, I'm in the UPPMAX directory. Yes, I am, good. Then I'm going to take this one here, and then I am going to change the directory in here so I can submit it. And that should be the only thing that needs to be changed on the UPPMAX one, like that. So I will submit it like this. And now you can see it submitted the batch job, and it tells you it submitted it to cluster snowy. So now we could see with this command here, you'll see it doesn't show anything. And you use arrow up to see the same command. And then I can add -M and snowy. And there you can see it's now pending to run on snowy. But we have already seen what the result is here. So, I mean, we don't need to wait for this. It will, as you can see in this example here, it doesn't throw it to any special output file. So that means it will go to an output file named slurm -thisjobid.out. So after a while, it will probably just do that. So let's continue instead. And just one more thing that is important when you're doing machine learning code, you're almost always running several iterations of it. And you will probably do that with changed parameters, or you will add or remove layers to see how it goes and see what works best. And when you do that in a batch job, the easiest thing is to either make a batch script that submits several variations of your Python script, or make a script that loops over and submits job with the changes. And here I'm just quickly showing how you could run several programs or variations of it inside of one. And this example is also here in the UPPMAX directory, so you could try that with some TensorFlow program you have. But what you would do here is now you would need to send first one here, and then you send it to some output file, because you probably don't want all of it to end up in one same output file. So what you could do is that you simply send it to a specific output file for each iteration of it. And that is one good way of doing it. Another one is to combine it with the array example I showed you under the batch. And then it will also create different output files for each of the runs when you use this %A in the output file naming.